Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2020, paper 6, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're going to be having a look at November 2020 paper 6 from OCR. Let's get into it. Question 1. A travel agent records the duration and cost of 15 flights he sold on one day. The data for the first 13 flights are plotted on the scatter diagram. The data for the first 13 flights are plotted on the scatter diagram. Now it says part A, the data for the final 2 flights is, and then I've got the cost and duration of 2 more flights. I need to plot these on the scatter diagram. So the first one is 210 and 130. So I need to find 210 on the graph and 130 on the graph. Read up from 210, read across from 130 and plot my point. So I think it's going to be about there then. Okay. And then I've got a second point, which is 1 hour 40 minutes against £80. Okay, now that's in a different form, isn't it, that one? Let me just convert that into minutes first, because the bottom scale is in minutes. So an hour and 40 minutes, that's 100 minutes, isn't it? Okay, so that's 100 against 80. So 100 against 80 is here in the middle. Okay. So that seems to be everything. So we've done that part. Part B says the cost of one of the 15 flights has been discounted in a sale. Circle the most likely flight on the diagram. Okay, so all the rest kind of line in a fairly much a straight line, but we've got this one down here, haven't we, which is kind of sitting all on its own. That one is our outlier, so I assume that one's the one that's been discounted. So it should, you know, all the ones at about 210 have been up at the cost of about 130, haven't they? So that one is significantly lower. So I think that's the one that's been discounted. Draw a line of best fit on your diagram. Okay, we need to get a ruler out. You can see the points are kind of marching up in this direction. It's positive correlation. Just try and get your ruler so you've got about a similar number of points on either side of the line, kind of following your main line up. Doesn't have to go through the origin, and actually if you force it through, you can get marked down for that. Okay, mine goes something like that. Okay, and then use your line of best fit to estimate the duration of a flight costing £90. Okay, so how long would a flight costing £90 be? Okay, what I'm going to do is I'm going to look up £90 on my scale, which is about here, and then I'm going to read across to my line of best fit and then change directions and read down from there. Okay, mine comes out to be somewhere between the first and the second line there. Now there are 5 divisions between 100 and 150, so each one of those is going to be worth 10. So I think that's pointing at about 105, something like that, 105, 110, something like that. Now yours might not be exactly the same because you might have drawn your line of best fit slightly differently. Don't worry about that. As long as you're within half a square of your own mark on your own diagram, then that's fine. Finally, explain why the travel agent should not use his records to estimate the cost of a 7-hour flight. What we just did there is an example of interpolation, because the value we looked up is between our kind of known points. We know from here to here, don't we? We all know this area here. So looking up within that range is fine. It's called interpolation. Now, when you're trying to look up beyond the edge of this line, which a 7-hour flight would be, what's that, 350 minutes? That's kind of beyond our last point. We call that extrapolation, and it's not that reliable, or we have no evidence to say that it's going to be following the same pattern. Okay, so this would be extrapolation, and is unreliable. Okay. Question 2, solve 3x plus 4 is less than 19. Show your solution on the number line. Okay, so inequalities we can solve in exactly the same way as we solve equations, if we're careful. So if this was an equation, if that sign in the middle was an equal sign, I'd be looking to isolate x, get by itself. So I'm going to be subtracting 4 from both sides. That's going to give me 3x is less than, that's going to cancel that, isn't it? And I'm going to be left with 15 on the other side. So 3x is less than 15. And then dividing both sides by 3. That's going to cancel with that. And I'm going to be left with x is less than 5. Okay? Now I can show that on the number line by putting an open circle above 5. Now, if it was less than or equal to, I would fill that circle in, okay? Because the 0.5 would be part of my solution. But because it's strictly less than, I use an open circle on 5, okay? And then I'm going to point at all the values less than 5. So I'm going to draw a line with my ruler going off to the left from that point. Okay, so and carrying on in that direction. Question 3, the graph shows the cost of electricity with company A. And it says use the information on the graph to estimate the cost of electricity for a customer who uses 450 kilowatts of electricity. Sorry, kilowatt hours of electricity. Okay, so similar to question 1, I'm just going to find 450 on the graph. Oh, it's not there. Okay, but it's going through 0, so I could look up like half of that and then double it up, couldn't I? That's what I'm going to have to do. Okay, because my graph only goes up to 250 and I can't use it to look up 450. I'm going to divide 450 by 2 and get 225, and I'm going to look up from 225, reading up from 225 until I hit the curve or the line, and then go in the opposite direction. Okay, so you can see that 225 kilowatt hours is equal to 28 pounds. So then if I double that up, then I'm going to get 450 kilowatt hours. That's going to be twice 28 then, isn't it? It's going to be 56 pounds. Okay, so it's 56. Company B charges 14.3 pence per kilowatt hour of electricity used. If company B's cost of electricity is plotted on the same axes as company A's cost of electricity, which line would be steeper? Explain how you know. Okay. Well, company B charges 14.3 pence per kilowatt hour. So what does a company A charge first off? If I look at 100, so if I read up from 100, then Then I hope you can see that 100 kilowatt hours costs about, what's that, £12.50. So for company A, 100 kilowatt hours equals £12.50. So dividing both sides by 100, then 1 kilowatt hour is going to be that divided by 100. It's going to be 12.5 pence, then, isn't it? Okay, so I can see from that then that company A is going to be cheaper. So if company A is cheaper, then for every 1 kilowatt hour you're going along, you're going to go 12.5 pence up. Company B, for every 1 unit you're going along, you're going to be going 4.3 pence up. So that one's going to be steeper. Okay, so company B is going to be steeper because gradient of company A is 12.5 p per kilowatt hour, whereas company B is 14.3 pence per kilowatt hour. Okay. Question 4. Nina estimates the value of that horrendous sum there by rounding each number to one significant figure. Show that Nina's answer is 64. Okay, so if I'm going to round this one off to one significant figure, then I'm just going to highlight the first significant figure of each number. Okay, so from the 3.93, you can see that the first significant figure is the 3, so that's a unit. So I'm going to round off to the nearest unit. So 3.93 to the nearest significant figure, to one significant figure, is going to be 4. Now the 3 in 393 is in the hundreds column. So if I'm going to round that off to one significant figure, that's going to be 400 to the nearest 100. And then in the one underneath, the denominator, I've got 0.546. The 5 is in the tenths column, so I'm going to need to round off to the nearest tenth, which is 0.5. And then finally, the first significant figure is in the hundreds column, so I'm going to round off to the nearest 100. That is 200. Okay, so that is what the numbers are rounded off, and then I need to cube that and then square root it, don't I? Okay, so the top times in the top. No, actually, I think I'm going to cancel this 200 into the 400 to start with. That's going to leave me with 2. And then 4 divided by 0.5. I suppose that's the same thing as 8 divided by 1, isn't it? So that's 8. And then times the 2, that's going to be 16. So actually, it is 16 to the power of 3 rooted. Now, I'm going to actually do the root first because root 16 is easy to do. It's 4, isn't it? So that's the same thing as 4 cubed, and 4 cubed is 96. Okay? So, I mean, strictly speaking, I've got the cube inside the root, but actually it's a bit like multiplying and dividing. It doesn't matter which order you do it in, you're going to get the same answer. So it's easier to do the root before it is to do the cube. Okay? So the answer is, why did I write 96? It's 64. So the answer is 64. Part B says, calculate the error in her estimated answer as a percentage of her exact answer. So what is the exact answer? Let me just type that into the calculator and find out. So it is the root of, open bracket, fractionally key, 3.93 times 393 on the top, and then on the bottom 0.546 times 220. Okay, close bracket to the power of 3. Okay, just double check, that looks good to me. That comes out to be 46.105. Okay, so then if I put that, her estimated answer as a percentage of her exact answer. So I need to put the estimated answer at the top, and then the exact answer underneath. Okay, so I'm going to write down 46.1, but I'm going to use the full display value. So 64 divided by answer, that comes out to be 1.388. Which is 138.8%. So therefore the error is, well, it's a bit above 100%, isn't it? Because you start with 100% and then, so the error is going to be 38.8%. Question 5a. Work out the size of the exterior angle of a regular 12-sided polygon. Well, that's easy. Each exterior angle it's going to be 360 for any polygon. It's 360 divided by n, which is where n is the number of sides. So in this case, it's going to be 360 divided by 12 because it's a 12-sided polygon. 12 goes into 36 3 times. That's 30 then, isn't it? So each exterior angle is going to be 30 degrees. Okay, and then use your answer to part A to write down the size of the interior angle. Exterior angles and interior angles make, well, lie in a straight line, don't they? So this is the exterior angle. This is the interior angle. So they lie in a straight line, so they add up to 180 degrees. So each interior angle is going to be 180 minus the exterior angle, which is 30, which gives you 150 degrees. Question 6. A truck is used to transport some wood panels. Each wood panel is a cuboid measuring 2.4 meters by 1.2 meters by 1.8 centimeters. It's in bold. Obviously, it's something that students often miss. The density of each wood panel is 750 kilograms per cubic meter. The truck can carry 12 tons of these wood panels. Calculate the maximum number of wood panels that the truck can carry. Show how you decide. Okay. So I think what we need to do is work out the volume of these panels first off. So we already, the measurements are here, aren't they? Okay, so let's work out the volume first. Now they're a cuboid, so the volume of a cuboid is just simply length times width times height, isn't it? Okay, now the length is 2.4, the width is 1.2, and the height is 1.8 centimeters, which in meters is 0.018 then, isn't it? Because there are 100 centimeters in a meter. So 1 centimeter is going to be 0.01 of a meter. Okay, so that's what I've got. What's that then? 2.4 times 1.2, 2.4 times 1.2 times 0.018. That means that each panel is 0.05184 of a cubic meter. Okay, right, so then the density of each wood panel is 750 kilograms per cubic meter. So then the mass of these then, the mass is going to be, well, density equals mass over volume, isn't it? So mass is going to be density multiplied by volume, which is going to be 750 kilograms per cubic meter times my 0.05184 cubic meters. So 750 times by our last answer comes out to be 38.88. So they weigh 38.88. What's the units? It's going to be in kilograms, isn't it? Kilograms per panel then, isn't it? 38 kilograms, 38, almost 39 kilograms per panel. Okay, so the truck can carry 15 tons. Now this is a metric ton when it's written like this, and a metric ton is 1,000 kilograms. So this is actually 15,000 kilograms, isn't it? Okay, so how many panels that weigh 38.88 fit into the carrying capacity of the truck? So number of panels is going to be the 15,000 capacity of the van divided by the weight of one panel then, isn't it? Okay, what's that then? 15,000 15,000 divided by 38.88. That comes out to be 385.8. Now, if I should really round up, shouldn't I? Because it's closer to 386. But actually, then that would be too heavy. That would exceed the carrying capacity of the truck. So in this case, even though 0.8 is closer to, you know, the next number up, I'm going to round down. So that's 300 and well, let's write it down, 385.8, and we're going to say therefore 385 panels can be carried. Question 7, vectors A and 4B are drawn on the grid. And then part A says, write vector A as a column vector. Okay, so column vectors are written in the form x over y, where x is the distance from one end of the vector to the other in the direction of x. So you can see that's 4 units in that direction. And then in the direction of y, which is, it's actually, y is how many units up it is, and this is actually 2 units down, so this is considered to be -2. So the column vector is going to be 4 units in the direction of x and -2 units in the direction of y. And then part B says, find the vector B as a column vector. Okay, now we've actually got 4B here. It doesn't actually fit nicely on the grid. I'm just gonna work out what 4B is first, and then I'm going to divide it by 4, I think. So 4B, that is equal to, I'm going to do the same thing. How many units in the direction of x and how many units in the direction of y do we need to go? Well, this is 1, 2, 3, 4 units in this direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, they're being a bit cruel to us here. So that's going to be 4, 9 then. So the vector B by itself is going to be a quarter of that then. So it's going to be a quarter of 4, 9, which a quarter of 4 is just 1, isn't it? So the top number is 1. Now the bottom number is going to be 9 divided by 4, which is, I'm just going to write it as 9/4 actually. So it's 9/4. 1 and 9/4. Question 8, Lee has T toy bricks. She only has red bricks and blue bricks. Lee picks 2 bricks, one after the other. If the first brick she picks is red, then the probability that the second brick is red is 2/3. And if the first brick she picks is blue, the probability that the second brick is red is 7/10. Calculate the value of T. Okay. So, just going to kind of draw a quick tree diagram to show all these possibilities then. So she can either pick a red or a blue brick on the first choice, and then a red and a blue brick on the second one, and a red and a blue brick on the second one. Now we're told that the probability that she picks red the first time, then a second red is going to be 2/3. Okay, and then the probability then, if she picks a blue one first, the probability that the second brick of red is 7/10. Okay, so what does that tell us? Well, if you have a look at the denominators of these two numbers, I've got a 3 here and a 10 here. Now these two numbers are going to have to be factors of our number of bricks that we had to pick from at this point, okay, which is 1 less than the total number of bricks because we've already picked one here. So the number of bricks left on the second selection is going to have to be a multiple of 3 and 10. Okay, so the smallest possible number it could be is 30. It could be higher than that. It could be 30, it could be 60, it could be 90. Okay, so I'm going to assume it's the smallest possible value it can be. I'm going to say that there are 30 bricks at this point, in which case that 2/3 I could rewrite as 20/30, and that 7/10 down there I could write down as 21/30. Okay, So that means at this point here, there must have been 31 bricks to pick from. And there must have been one more red brick at this point then, mustn't there? Okay, I could probably go further. I could work out the rest of the diagram here as well. This would have to be 10 over 31. This would have to be 10 over 30. And this would be 9 over 30. But actually, what am I wanting to find out? I want to find the value of t, which is the total number of toy bricks. So that's just going to be this 31 here then, isn't it? I'm going to say t is equal to 31. Question 9. X is directly proportional to y. Y is directly proportional to z. When x is 10, y is 60. When y is 8, z is 1.6. Find the formula for z in terms of x. Okay. Well, let's do it. Let's do the first one first. X is directly proportional to y. So x is proportional to y. Then we can replace that symbol of proportionality with equals k. So x equals k lots of y. Now we've got two values that link x and y together. We can use these to find the value of k, the constant of proportionality. So when x is 10, y is 60, so subbing that in, then 10 is equal to k lots of 60. Okay, so then k is going to be, so that makes k equal to 10 divided by 60. It's 1/6, isn't it? And therefore the full equation that links a and y is that x equals y over 6, or a sixth of y. Okay, so that's my equation linking x and y. I'm going to do the same thing for the other one now. Y is directly proportional to z. So doing the same thing, y is proportional to z, which means y is equal to some constant times by z. Again, I've got a pair of values that link y and z. So y equals 8 when z is equal to 1.6, which I can use to find the constant of proportionality. So when y is 8, z is 1.6. So 8 equals k lots of 1.6 then. So k is going to be 8 divided by 1.6. 8 divided by 1.6, which apparently is 5. So k is 5. So then y equals 5 lots of z. Okay? So I've got two equations. I've got equation 1 where x equals y over 6, and I've got equation 2 where y equals 5z. So what I'm going to, and what do I need to do? I need to find a formula for z in terms of x. Okay, so I think the first thing I'm going to do is I'm going to use the fact that this y here I can rewrite in there, couldn't I? Or 5z. I can replace y in equation 1 with 5z because I know that y is equal to 5z. So I'm going to substitute equation 2 into equation 1, and that's going to give me x equals, not y over 6, I'm going to replace y with 5z, so x equals 5z over 6. Okay, now I've got an equation in x and z now, but it does say find a formula for z in terms of x. So in other words, I need to make z the subject. Okay, so I'm just going to do that by cross multiplying these two numbers here. This 6 is going to end up here. This 5 is going to end up down here, isn't it, if I cross multiply? So I'm going to get z equals x. The 6 is going to come up. The 5 is going to go down. So z is 6/5 of x. Okay, z equals 6x over 5. Question 10. Paintings are sold in an art gallery. The cost of a painting has k% commission added to it. Tax of 15% is then added to the total cost to give the price to pay. Now Layla correctly calculates the price to pay by multiplying the cost of the painting by 1.403. Work out the value of k. Okay, so the multiplier we've been using here then, the multiplier is 1.403. Now this multiplier of 1.403 has got to be equivalent to the two percentages that the gallery is adding onto the painting. So they take the cost of the painting and they're going to multiply it through by the multiplier for the percentage commission, and then they're going to multiply it again by the 15% increase, and that results in an overall multiplier of 1.403. Okay, so I'm going to say, because we don't know what this commission is first, let's call the first multiplier commission multiplier. Is going to be, I'm just going to call that M because I don't know it at the moment. And then you've got the tax multiplier. Now if you've got 100% and you increase it by 15%, you've got 115%, which is 1.15 as a multiplier. Okay, so my multiplier of the M times the multiplier of 1.15, that has got to be the same thing as my multiplier of 1.403 then. Okay, so in other words, if I want to find my multiplier here, I'm going to divide both sides by 1.15 then, aren't I? So then M, my commission multiplier, is going to be 1.403 divided by 1.15, which is 1.403 divided by 1.15. That comes out to be 1.22. Okay, which is 122%, isn't it? Which means that the commission K must have been 22% then. So the 22% commission they added on would result in a 1.22 multiplier, and then the tax would be a further 1.15, and 1.22 multiplied by 1.15 is 1.403, so it seems to all work. Okay, commission is 22%. Question 11, here are two functions. I've got function A, which is a times 3 plus 15 function, and B, which is a plus 11 times 2 function. Part A, part 1 says, Joe chooses a number x. She inputs x into each function. The two outputs are equal. Work out the value of x. Okay, well, if I feed x into the first one, it's going to be multiplied by 3, which is going to give me 3x. And then a 15 is going to be added on, so it's going to be 3x plus 15. Okay, if I add feed x into the second one, first off, I'm going to add 11 to it, and then I'm going to multiply it by 2. Now I need to put that in brackets and put it that way around, otherwise I'm just going to be, because of BidMaths, I'm going to get the answer wrong. So it's 11 plus x plus 11 in total gets multiplied by 2. Now we know that these two things are equal, so we can equate them. So 3x plus 15 is equal to, I'm just going to multiply that out. So 2 times x, 2 times 11, that's going to be 2x plus 22. Okay, and then I'm going to collect things, x's on the left and numbers on the right. So taking 2x off both sides, I'm going to get x is equal to, I'm going to take 15 off both sides. So that's going to cancel with that, that cancels with that. Take away 15, I'm going to get x is equal to 7 then, aren't I? X is 7. Part 2 says, explains why there is no other input that gives two outputs that are equal. Well, it's due to the fact that these are both of these are what we call linear functions. If you're going to draw them as a graph, you get two straight lines, wouldn't you? Okay, and two straight lines can only intersect at one place. So there's only ever going to be one value that is the same, okay, on both lines. Okay, and there's only one point that can be on both lines at the same time. So I'm going to write that down. They are both linear functions which can only intersect in one place. Part B says, here is function C. The input, we add P and then we multiply by Q. Kai chooses for P and Q so that if he inputs any number into both function A and function C, he will always get two outputs that are equal. Find the value of P and the value of Q. Well, if you remember, function A was times 3 plus 15 as a function. And so it was equivalent to 3x plus 15, wasn't it, as a in kind of algebraic terms. Now, if I put x into this function, I'm going to get x plus p times q, aren't I? Now, if these things, which is the same thing as qx plus pq, isn't it? Okay. Now, if these things are the same, these got to be true. These got to be the same for all values. Then in this case, these got to be the same. Now, comparing the left-hand side with the right-hand side, can you see I've got a q in front of the x, and that's the same thing as that. That must be the same thing as that 3 there, then, isn't it? So my value of q must be equal to 3. And my pq part here must be the same thing as 15. So if pq equals 15, and I know that q is 3, then p is going to be equal to 5, then, isn't it? So they're my two solutions. If these are equivalent functions, then it must be that q is 3 and p is 5. Okay, so I think I'm going to just come back and add something to this one. So in the last example, we had two parallel functions, or one function was equivalent to the other one. So I think I'm going to say that these are both non-parallel linear functions. Okay, so they're not parallel and they're not on top of each other, so they're only going to intersect in one place. I think I'm a bit happier with that answer now, having looked at part 2. Question 12. Students are asked to choose one subject from option A and one subject from option B. If a student chooses their subject at random, what is the probability that both subjects have the same first letter? Let's work out the total number of selections. Okay, so I've got 4 choices for option A, and I've got 1, 2, 3, 4, 5, 6, 7 choices for option B. So you could pick any from option A and any from option B. So that's 4 times 7. That's 28 different outcomes, isn't there? Okay, so there's 28 different combinations that you can pick. Now, how many of those combinations have the same first letter? It could be economics engineering, so that's 1. Any other possibilities? Could be media studies and music. That can go together. It's a second possibility. History, no. Geography, or it could be geography, German, or it could be geography, graphics. That's also a possibility, isn't there? So there's actually 4 combinations then where the first letters are the same. Okay, from the two choices. So therefore, the probability, same first letter, probability is successful outcomes over total outcomes, isn't it? We've already calculated that the total outcomes is 28, and we've just seen that the number of options that have got the same first letter are 4, so it's 4 out of 28. Okay, now I could cancel it down, but yeah, I suppose I could cancel it down, but you know, just bear in mind that if you do and you get it wrong, you lose a mark, whereas if you don't lose a mark, so you might as well not bother actually. So it's 174428. Question 13. In the diagram, AED and ABC are straight lines and BE is parallel to CE. The ratio of lengths AB to BC is 2 to 3, and the triangle ABE has an area of 8 centimeters. Work out the area of the triangle ACD. Okay, so let's first think about what is the ratio of the lengths. Ratio of lengths. Now we're interested in the two triangles ABE and the other one ACD, aren't we? They're the two triangles we're interested in. Now what are the ratio of the lengths? Now we're told that the ratio of length AB, which is this length, to the ratio of BC, which is this length, is 2 to 3. Okay, so that's 2 and that's 3. So the ratio of AB to AC, remember, if I want to compare the triangles, I have to actually look at that length, not the B to C, but actually A to C, which is actually going to be like 5 parts, isn't it? Because I've got the 2 parts from A to B and the 3 parts from B to C. So the ratio of the lengths of these two triangles is not 2 to 3, it's actually 2 to 5. Okay? So then, ratio of their areas is going to be the square of that, then, isn't it? So it's going to be 2 squared, which is 4, and 5 squared, which is 25, because the ratio of areas is always the square of the ratio of the lengths in similar shapes. Okay, and these are similar shapes because they share 2 lengths actually, and so all the angles are going to be the same, aren't they? Because those 2 lines are parallel. We know that that angle is the same as that one, and we know that this angle is the same as that one, and they share that one, don't they? So I suppose we should say that they're similar triangles. So let's just state that as well. So ABE, triangle ABE is similar to a triangle ACD. Okay, so we need to know that so that we can work out this ratio of their areas is 4 to 25. So that's true. So, and we're told that the area of triangle ABE then is 8. Okay, which you can see is twice this one. So then if I double this up as well, I'm going to get 50. Okay, so if this area in here is 8, then the area of triangle ACD then is going to be 50. Therefore, area of triangle ACD is 50 centimeters squared. Question 14. The base of a cone is fixed to the top of a cylinder to make a decoration. The radius of the base of the cone and the cylinder is r centimeters squared. The cone's height is 5r centimeters squared, and the total height of the decoration is 6r centimeters squared. The total volume of the decoration is 225 centimeters cubed. Calculate the value of r, show your working, and we can use the fact that the volume of a cone with a radius r and the height of h is v equals 1/3 pi r squared h. Okie dokie. Right, so I think what we're going to have to do is we're going to have to work out the volumes of these 2 shapes in terms of r. Then we're going to have to equate it with the total volume we've been given, and then hopefully r drops out of it somewhere. So let's start by finding the volume of the cone. So vol of the cone, what's that then? That's going to be, well, we've got the formula for it down here, haven't we? It's 1/3 pi r squared h. So let's just write that down first, and we'll sub in what we got from the diagram into it. So 1/3 pi r squared h. Now r here is actually r, isn't it? We've got a radius of r. But h, the height of this cone, it's going to be, it's 5r. So we're going to replace h with 5r being the height of the cone. So that's going to be 1/3 of pi times r squared times 5r. Okay, I'm just going to tidy that up. That's going to be 5/3 of pi r cubed, then, isn't it? Okay, so that's the volume of the cone. Now let's have a think about the cylinder. Vol cylinder. Okay, what's that then? That is going to be well, what is the height of the cylinder? So if that's, we know the height of the cone is 5, so if this is 6, then the cone then, sorry, the cylinder is going to be 6 take away 5, that's going to have a height of r, isn't it? So the volume, so a cylinder is just a circular prism, isn't it? And the volume of a prism is equal to its cross-sectional area, which in this case is a circle, it's pi r squared, times its height. Okay, so that's the formula for a cylinder. Now the height for this one is r, r is r still, so it's just going to be pi r squared r, which is pi r cubed. Okay, so then the total volume, that's going to be the volume of my cone plus the volume of my cylinder. And so that is 5/3 pi r cubed plus pi r cubed. Okay, which is one lot of pi r cubed, isn't it? So we've got 5/3 of pi r cubed plus one lot of pi r cubed. So I can add the 5/3 and the 1 together. Or you can think about factorizing out. I suppose that might be easier for you to see. So if I factorize pi r cubed out, it leaves me 5/3 plus 1 then, doesn't it? So what's 5/3 plus 1? 1 is 3/3, so 5/3 plus 3/3 is 8/3. So that is 8 over 3 pi r cubed then, isn't it? Okay, so that's the total volume. Now we're told somewhere what it is, aren't we? So we were told that the total volume of the decoration is 225. So if we're saying that this is equal to 225, then we've got kind of an equation in r that we can then solve then, isn't it? So if I can say that, I can create some more space for myself to do some working over here. So we've got 8/3 of pi r cubed, and we're saying that that's equal to 225, aren't we? Okay, so cross multiplying the 3 and the 8 first off, that's going to give me pi r cubed equals 225 times 3 divided by 8. Okay, so what's that? Let's just multiply the 3 and the 225 together for now. That's easy to do, isn't it? It's going to be 675 over 8. And then I'm going to cross multiply the pi as well. So it's going to end up on the bottom. So it's going to be 675 divided by 8 pi. And then that's going to be r cubed, then, isn't it? And then so to find r, I'm going to have to cube root all of that. So it's going to be the cube root of 675 over 8 pi. Okay, so I'm going to type that horrendous thing into the calculator. So cube root, and then I'm going to use the fraction key, I think, to type this in. So 675 on the top and 8 pi on the bottom. What does that come out to be? That's 2.99 and change, isn't it? I'm going to round it off to 2.99. 2.99 units. It's going to be in centimeters. So r is 2.99 centimeters. Question 15. A bus company has a large number of buses. 25% of the buses are more than 10 years old. If a bus is more than 10 years old, the probability that it will start first time is 0.3. If the bus is less than 10 years old, the probability that it will start first time is 0.65. Amir is asked to drive one of the company buses, chosen at random. Calculate the probability that the bus starts first time. Okay, so I'm gonna start this off by drawing a kind of like a probability tree. So the first branch, I'm going to consider whether or not the bus is more than 10 years old or not. So I'm going to say, is it old or not old? Okay, so the probability that it's old is 25%, isn't it? As a fraction, 25% is 25 over 100, which is 1/4. So 1/4 of the buses are old, and that means that 3/4 of the buses are not old. Okay, and then in the second kind of branch of my tree diagram, I'm going to consider if it starts first time or doesn't start first time. So starts, doesn't start, starts, doesn't start. Okay, so if it's old, so if the bus is more than 10 years old, the probability that it will start first time is 0.3, which means there's a 0.7 chance that it doesn't. And if the bus is less than 10 years old, the probability that it will start first time is 0.65. So start 0.65, which means the probability it doesn't start is 0.35 down there. Okay, so I need to then calculate the probability that the bus starts first time. So that is going to be this root, old and starts, or this route, old, not old and starts. Okay, so what's the probability of old and starts? That's going to be 1/4. Kind of mixed my units a bit here, haven't I? I suppose I should have written that as 0.25. 0.25 times 0.3. And then the probability of not old starts is equal to 0.75 times 0.65. Okay, just going to work out what those two are. So 0.25 times 0.3, that comes out to be 3/40. And then 0.75 times 0.65, it comes out to be 39/80. Okay, so then probability that it starts is going to be those two outcomes added together then, because it's either going to be one or the other. So it's the probability of old and starts plus the probability of not old and starts, which is 3/40 plus 39/80. Now 3/40 is the same thing as 6/80, isn't it? So 6/80 plus 39/80, that's 45/80. Okay, so that's my probability, 45/80. Now that probably cancels down. If I type it into my calculator, 45/80, it does cancel down to 9/16. But you know, you don't actually get a mark for that. So you could have just left it as 45/80. For some reason, you never get a mark for cancelling down or simplifying fractions in probability questions. So it's up to you whether or not you bother doing it. Question 16, the diagram shows a circle, centre O. Points A, B and C line the circumference of the circle. Line AOB is the diameter. Line DAE is a tangent to the circle, and angle CAE is 32. Now I've just been reading, as I've been reading through that, I've just been checking that all this information is already on the diagram. Please always read through this because it isn't always on the diagram, so it's always worth just double checking everything is there before you proceed. Okay, so part A says, give a reason why angle ACB is a right angle. Well, that's pretty easy enough because that's one of our rules, isn't it? Okay, there's certain circle theorems that we need to know, and one of them is that the angle subtended in a semicircle is a right angle. Okay, so basically it's subtended off this diameter, isn't it? So the angle is formed off the diameter that's drawn through the center of the circle, so that means this is going to be 90 degrees always. It's just a rule for circle theorems that you need to know and use. Okay, now the second part says the radius of the circle is 8. Calculate the length BC. The radius of the circle is 8. Calculate BC. Right, so if the radius is 8 centimeters, then the diameter then is going to be 16 centimeters, isn't it? Okay, so it's double the radius. So it's 16 centimeters from here down to here. So the line AC is 16. Okay, I've also got this angle here, which is 32 degrees. And I'm going to use another circle theorem that says, well, it's called the alternate segment theorem, which says the angle between a chord and a tangent drawn at the point of contact is equal to the angle in the alternate segment, which means that that one there basically is 32 degrees. Okay, so now I've got a right angle triangle where I know one side and I want to find another side. Okay, so relative to that 32 degree angle, this side over here would be the adjacent, and the 16 is opposite the right angle, so this is the hypotenuse, isn't it? Okay, so I'm going to be using SOHCAHTOA here. Okay, so SOHCAHTOA in order to identify which ratio I'm going to use. Okay, so I want the adjacent and I've got the hypotenuse. So which ratio has got to do with the adjacent and hypotenuse? It is the cosine, so cos. So I'm going to write down the cosine formula. Cos theta is equal to adjacent over hypotenuse. Subbing what I know from the diagram, so the angle is 32 degrees, so that's cos 32 is equal to the adjacent. That's what I'm trying to find. I want to find the side BC. Let's just call that x for now. X over the hypotenuse, which is 16. Cross multiplying that 16. Okay, it will end up moving over there. I'm going to get 16 cos 32 is equal to x. Time to grab the old calculator and tap it in. So 16 cos 32, that comes out to be 13.56. I'm going to round that off to 13.6. So x equals 13.6 centimeters. Okay, and that is my length BC then, isn't it? So BC is 13.6. Question 17. Here is a sequence, and I've got 3 root 5, 15, 15 root 5. Okay, work out the next term. Now, what sort of sequence is this? It might not be immediately obvious to you, but this is actually a geometric progression. If you look at this term to this term, I'm multiplying 3 by root 5, and I'm going to get 3 root 5, and that's pretty easy to see. But what do I have to multiply 3 root 5 to get 15? Well, actually, I need to multiply it through by another root 5, don't I? Because root 5 times root 5 is 5, and 3 times 5 is 15. You can just double check that on your calculator, but you should find that multiplying 3 root 5 by root 5 is going to give you 15. And then from there to there, we're multiplying by another root 5, aren't we? From 15 to 15 root 5. Okay, so the next one along, I'm going to get by multiplying by another root 5. So root 5 times root 5 is 5, and 15 times 5, then what's that? That's going to be 75. So the next term is 75. So it's going to be 15 root 5 times root 5, which is 75. And I need to find the nth term. So what's un for geometric progression? Now, remember, these series, they start off with a first term a, and then you're multiplying it through by a common ratio. So this would be ar squared, ar cubed, and so on. Okay, so if you want to know what the nth term is, I don't know if you can notice that the first term doesn't have an r in it. So what we need to say is then that the nth term is a times r to the power of n minus 1. Okay, so for the first term, when n is 1, you get r to the power 0, which is 1, so it just gives you a first term of a. And then the next term, you're going to get like a times r to the power of 2 minus 1, a to the power of r, and for the third term, you're going to get ar squared, and so on. So that does work. So then we worked out that a then, what's a? A is 3, isn't it? The first term is 3. And the common ratio is root 5. So it's 3 lots of root 5 to the power of n minus 1. That's going to be the nth term. Question 18, write 0.416. This is a recurring number with dots on the 1 and the 6 as a fraction in its simplest form. You must show full working to support your answer. Okay, so I've got 0.416 with a dot on the 1 and a dot on the 6. Okay, and that's going to be, I'm going to say let that be x. Okay, so then x is equal to 4, and then the 1 6 1 6 pattern is repeating, isn't it? It's 4 1 6 1 6 1 6 1 6 and so on. Okay, now if I multiply that by 100. So 100 lots of x, I'm going to get, well, I'm going to get all these sequence of numbers moved over 2 decimal points, aren't I? I'm going to get 41.616161616 and so on. Okay, and so then if I subtract one from the other, I'm going to subtract uphill. I hope you don't mind. I don't really want to rewrite it the other way around. So I'm going to take 1 lot of x away from 100 lots of x. So 100x take away x. That's going to give me 99x. And that is equal to, well, I hope you can see that all this 161616 cancels with all of that 161616. So essentially what I've got is 41.6 take away 0.4, which is going to give me 41.2. Okay, so then Dividing both sides by 99, that's going to give me x equals 41.2 over 99. Now that's not a very good fraction because I've got like a decimal in it, haven't I? But if I multiply top and bottom by 10, I can get rid of that decimal and rewrite this as 412 over 990. Okay, that's my final answer. 412 over 990. Question 19. The graph of y equals 2x squared plus 3x minus 9 is drawn below. And you can see I've got a quadratic curve that kind of matches up with that. So it says use the graph to solve 2x squared plus 3x minus 9 is equal to 0. Okay, so the equation I'm trying to solve is the same as my graph, isn't it? Okay, so the same as this one up here. So all I need to find then is the roots of this graph, which is where it crosses through the x-axis, so that point there and that point there. So all I've got to do is read those numbers off the x-axis. So the one on the left is minus 3, isn't it? X equals minus 3. And then the one on the right looks like 1.5 to me. 1.5. Okay. Now, the equation 2x squared plus x minus 4 can be solved by finding the intersection of the graph y equals 2x squared plus 3x minus 9 and the line y equals ax plus b. Find the value of a and the value of b. So I can simply do that by subtracting one equation from the other. So if I got 2x squared plus 3x minus 9, which is the equation of my graph, and I subtract from it 2x squared plus x minus 4, then that's going to leave me with 2x, 3x take away x is 2x, minus 9 take away negative 4, that's going to be negative 5, isn't it? So it's 2x minus 5. Okay, so then a is going to be 2 and b is negative 5. And the equation I want is y equals 2x minus 5. Okay? Hence, use your graph to solve the equation 2x squared plus x minus 4 is equal to 0. So I just need to plot that equation y equals 2x minus 5 on my graph. Now, I tend to do that just using the gradient and the y-intercept. Now, the negative 5 part is the y-intercept, isn't it? It's the value of c. And the gradient is the coefficient in front of x, which is 2. Now, that tells me that my graph needs to cross through the y-axis at negative 5, and it also tells me for every 1 unit I go along, I'll go 2 units up, so I can use that to work out the point. Okay, I just noticed that when I drew this, when I plotted this graph out, then the axes have gone a bit wonky, so I'm just going to count down, so minus 1, minus 2, minus 3, minus 4, minus 5. Minus 5 is actually that point there on my graph, it's just the numbers have gone a bit weird. And then, so a gradient of 2, so y-intercept is minus 5, gradient of 2 means for every 1 unit I'm going along, I'm going to go 2 up, which would take me to here. So if I go 1 unit along, I'm going to go 2 units up. So 1 unit along takes me from 0 to 1, and 2 units up takes me from minus 5 to minus 3. And then they carry on the same way. 1 along, 2 up is going to take me to minus 1. 1 unit along, 1 unit up is going to take me to 3, 1. And going the other way, 1 unit to the left and 2 units down, it's going to take me to that point. 1 unit along, 2 units down to that point there. Okay, and I think that's enough points. I think I can then draw my graph through those points. Now, if you don't want to do it this way, you can also do it on your calculator. If you go to the table mode in your calculator by pressing menu and then I think it's 3, you can type in the equation that you want to find the values for, so 2x minus 5 in this case, and then you can say what your range is, so you can pick in minus 3 to 3, that's the range of this graph. And then the step is what you want to go up in. So you go up in ones, and that's going to give you all the values then that you need. Okay, and then you can plot those on. Okay. So either way, you're going to get the line like this. So then what we want are the points of intersection, then, don't we, between our lines. And then we want to find the values of x for which those intersections occur. So you can see my first point of intersection is here, look, and my second one is down here. So reading up from there up to the graph, from there and also up to there. So reading that one off, that one looks like 1.2 to me. So I've got 1.2, the one on the right, and the other one looks like minus 1.7, I'd say. Minus 1.7. Question 20, vector m is 2k and vector n is 311. Vector 2m plus n is parallel to 1 minus 1. Find the value of k. Okay. So let's find out what 2m plus n is first off, and then we'll worry about the parallel bit in a minute. So the vector 2m plus n then is going to be 2 lots of my vector 2k plus my vector 311. Okay. So first off, I'm going to multiply out. I'm going to deal with this scalar here on the outside. Now I can do that just by multiplying everything inside the column vector by 2. So that's going to give me 4 2k. So 4 2k plus 311. And then I'm going to add like with like. So I'm going to add the 4 with the 3, and I'm going to add the 2k with the 11. Okay, so that's going to give me 7 2k plus 11 as my vector. Okay. Now we are told that that is parallel to 1 minus 1. Okay, so that means that this must be, if two vectors are parallel, it means that one must be a multiple of the other. So it's got to be some multiple of that vector 1 minus 1, like that. Okay, so in other words, 7 has got, and again, if I multiply that out, so 7 2k plus 11 is equal to m minus m. Then again, if I compare this one with this one, then I can see that m equals 7. And then if I compare this one with this one, then I can see that 2k plus 11 must be the same thing as minus m, which we've just found out is 7. So I can say that 2k plus 11 equals minus 7. Okay. Then subtracting 11 from both sides, I'm going to get 2k equals minus 7 minus 11 as minus 18. And then dividing both sides by 2, I'm going to get k is negative 9. K is negative 9. Now, if you're wondering where this m came from here, it's not mentioned anywhere in the question. I just made it up. I shouldn't really have used m because I've got another vector called m, so naughty, naughty me. I just meant that to be some sort of value like x that we don't know what it is yet, but we're gonna find out what it is later. Okay, so I introduced that m. It's not the same thing as this vector up here, because if you remember, I wrote my vectors with the line over the top so you could see that they were vectors. This is just a scalar. I just used it to show that that these two vectors were parallel. Question 21, write as a single fraction in its simplest form. Okay. Now, I've got x over x plus 2, I've got x plus 1 over x minus 2, and I've got 6x over x squared minus 4. Now, I'm immediately noticing this one over here. This is the difference of two squares, isn't it? And x squared minus 4, x squared minus 4 actually factorizes it out into x plus 2x minus 2. Okay, so if I was going to pick a common denominator for each of these three fractions, it would be x plus 2, x minus 2, wouldn't it? Because x plus 2 is in the first fraction, x minus 2 is in the second fraction, and x plus 2, x minus 2 is what is the denominator of the third fraction. Okay, so x plus 2, x minus 2 is a common denominator for each one of those three fractions. Okay, so then I can then use that, and then I can combine the numerators together now over that common denominator. Now, if you have a look at how many times x plus 2 goes into x plus 2, x minus 3, it goes in, sorry, x plus 2, x minus 2, it goes in x minus 2 times. Okay, so I need to then multiply this number on the top here by x minus 2. So it's going to be x lots of x minus 2 over there. Okay, and then I've got a plus sign, and I've got x plus 1 over x minus 2. Now, x minus 2 goes into x plus 2, x minus 2, x plus 2 times. So I'm going to have to multiply this one, x plus 1, by x plus 2. And then I'm going to make this a bit longer because it's quite a big chunky one. And then I've got another plus symbol, and I've got 6x over x squared minus 4. Now that x squared minus 4 is the same thing as x plus 2, x minus 2. So I simply write for the last one, I'm just going to write 6x in. Okay? Oh, I just noticed that I got that wrong when I typed it in. That should actually be a minus sign in there. So that over there should be a minus sign. Okay, sorry, I wrote the question down wrong. I typed the question down in wrong when I was typing it up. So my apologies for that. So it should be minus 6x on the end. Okay, x times x is x squared. X times minus 2 is minus 2x. And then doing the double bracket here, can do FOIL on those. So I'm going to get x squared plus 2x plus x plus 2, and then I've got a minus 6x on the end. Okay, and that's all over x plus 2, x minus 2. Okay, time to collect like terms. I've got 2 terms in x squared, which makes 2x squared. How many terms in x have I got? I've got a minus 2x, a plus 2x, a plus 2x, and a minus 6x. So what's that? Minus 2x plus 2x cancel, plus x and minus 6x. That makes minus 5x. And then constants, I've got a plus 2. Plus 2. And that's all over x plus 2, x minus 2. Okay. Now am I done? Now I've got a feeling that that quadratic on the top might factorize. So if it does, it's going to be a 2x here and an x here. Now I've got a positive term at the end and a negative term in the middle, and the only way that can happen is if I've got a minus and a minus. And the only factor pair of 2 is 1 and 2. So if I put the 2 here and the 1 here, then the 2x times the 2 is going to give me minus 4x, and the minus 1 times the x is going to give me minus x, give me minus 5x altogether. So that seems right, and that's all over x plus 2, x minus 2. And now, look, that one there cancels that one. So it just leaves me with the first bracket of each. Okay, so that's going to give me 2x minus 1 over x plus 2. And that, ladies and gentlemen, is it. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.